So, introduction to composite functions. What is the better deal? Do you take a 20% discount on an item first and then use a coupon? Or do you use the coupon and then take a 20% discount? Does the order matter? Answer the questions below to find out. Okay, if you want to get an oil change for your car at Scott's Auto Clinic, it normally costs $24, but you work there and receive a 20% discount. How much will the oil change cost you? You know how to take off 20%, pay. If you're taking off 20%, how much is the price for you? Okay, so you're paying what percent of the price if you're taking 20% off?
It'd be $2.40.
Like 40. So 19. 20. Okay, good. So listen to my question now. If you're taking 20% off, how much are you paying? How much percent?
80%.
80%. Okay. So one way we could do this, instead of having to find 20% and subtract it, we could just do 80%, right? Sleep, get out of the way. We could just do 80% of $24. So 80% would be 0.8. And that should give us the same amount if anyone wants to just try that multiplication. 1920, I think. Okay, you have a coupon for $4 off. How much do you pay for the oil change if you take the employee discount and then subtract the coupon? So we have our $19.20 for our employee discount, and we're going to take $4 off, which brings the price down to $15.20. Pretty sure this problem is obsolete and oil changes cost a lot more than this now. Anyway. How much will you pay if you subtract the coupon first and then do the employee discount? So let's take our 24, subtract the coupon first. So that brings it down to $20. And then our employee discount would mean that we are going to pay 80% of the $20. How much was that? Yeah. Okay, what's the better deal? No, the first one's better. Yeah, the discount first is better. How come? Yeah, since the initial amount is higher than the discount, which the 20% off is higher. Okay. The whole point of this, though, is did the order that it happened in that? Yes. All right. So that brings us to composite functions. With composite functions, we're basically taking something and plugging it into one function, and then taking it out of that function and plugging it into another function. So we plug something in, we get an answer out. We take that answer, plug it in, we get another answer out, and that's our final answer after it's gone through 2 or however many functions. So, order matters. That's kind of the main point of our little self-starter thing that we just talked about, is that order matters. So we have a couple of functions here, f of x and g of x and h of x. And we're going to practice doing some composites. Now the notation for composite functions has this little circle in between them. And it literally just means that we're doing, we would say it, g composite f of x, or we could say we're finding g of f of x. So just that's how you would actually say it. I know this one kind of looks like fog. Sometimes we'll say find the fog, but it's really composite is the proper word to use. So g composite f of x. That means we are taking f of x and we're plugging it into g of x. Okay, find and simplify expressions for the following functions. So we're going to take f of x and plug it into g of x. So here's f of x. This is the value that we're going to plug in, which means that's going to go into the x value right there. So finding g composite f of x, we always always start on the inside first. Start inside. So G composite f of x means we're plugging f into G. All right, so that's going to look like 1 over f of x is 2x plus 3, so 2x plus 3. Then our g of x function has a minus 1. So this is like the x part, because that's f of x. And that is the rest of the g of x function. Right? I just plugged in that little piece in place of x, which is f of x. And now I simplify it. So 1 over 2x plus 2. So that is our new composite function by putting those two functions together. On our little coupon problem, it would have been something like, we take the price, we'll call it P, and we do 0.8 of P, and then we subtract 4. Or the other way around would have been P minus 4, and then multiply by 0.8. So it's just the order that you're plugging one function into the other one makes the function what it is. Okay, what would f composite g of x look like? Yep. So that would look something like 2 over x minus 4 plus 3. We get the same function when we plug g into f instead of plugging f into g. Yeah, we got a different thing. We're going to talk about their domains in just a second. Okay, last one, h of f of x. Which one plugs into which one? Yes, because we go from the middle out. So f is 2x plus 3. So we're going to take square root. We're going to plug in 2x plus 3. And then add 4. So that gives us 2x plus 7. All right, now here's the thing about composite functions. When you find the domain of a composite function, you have to use both the domain of the function you're plugging in as well as the domain of your final answer. So for the domain of a composite function, we include domain of function you plug in. And of final answer. So let's look at each of these really fast. Let's just go ahead and find the domain of each of these functions. So for f of x, what's the domain? What's the domain of f of x, which is 2x plus 3. Does 2x plus 3 have any fractions, or square roots, or logarithms? So it's all real numbers. Okay, what about g of x? It does. So what number would make the denominator 0? 0 minus, we would plug in 0 for x, which was 0. So 0 minus 1 would be negative 1. It's okay to divide by negative 1. That's not the right figure. So 0 is actually okay. What number would turn it into 0? Positive 1. Does that make sense? So I'm not like saying it equals this, I'm doing the domain. So domain would be x cannot equal 1. Whereas this one, the domain was all the numbers. Okay, and then h of x, the domain. Oh, I did that one in a different color. Oh well. Okay. you can't take the square root of negative. So what can our domain be for that part? So we would normally take the stuff within there and then go greater than or equal to 0 and then solve it. Because the stuff in the square root can be 0, but it can't be negative. So it has to be greater than or equal to 0. So what's our domain for h? Okay, so I haven't found any domains of composite functions yet. All I've done right now is just written out the domains for f and g and h. That's it. Now let's look at our composites.
So this would be the functions of all the ones.
Yeah, that I just went ahead and found the domain of all the ones that we're taking. So now let's look at g of f of x. What are we plugging into that? Which function? Which function is the one that plugs in? F, right? And does f have any restrictions on its domain? No, it's all real numbers. So we don't need to worry about f because f is all real numbers, but we do need to worry about our answer. What number, if x was that number for our answer, would make this divide by 0? If you're not sure how to do that, you're just going to take your 2x plus 2 and set that equal to 0 and solve it. We don't want it to be 0. So what number would make the denominator of our final answer 0? Negative 1. So guess what the domain of our composite function g of f is? It is x cannot equal negative 1. That's the domain for that first problem. We considered two things. We considered the domain of f, which was all real numbers, so it didn't really matter. And we considered the domain of g of f, which our final answer x could not equal negative 1, or it would make it 0. So the domain of our final answer, the domain of that composite function is x cannot equal negative 1. So, done. Okay, let's do the next one. So the next one, we're plugging g into f. So for that one, our domain has to include what? What are we plugging into f? Plugging g into f. And what can that not be? What can x not be for function g? 1. It can't be 1. So right off the bat, we know x cannot equal 1 because that pertains to the function we're plugging in, that we're starting with. We can't plug 1 into that function, so we can't plug 1 into the function at all. If we can't plug it into the function that we start with, then we can't plug it in. Now we look at our final answer. What can we not plug into our final answer? We still just can't plug in 1. Is there anything else that we can't plug in to make that work? No, just 1. So that doesn't change anything. That's our answer right there. That's that one. Okay. I have a feeling this next one's going to be... No, actually the next one isn't bad, because what are we plugging in again? What are we plugging into our last one? We're plugging f into h, correct? So that means all real numbers is fine. So h composite f of x. So f of x is all real numbers, so we don't need to worry about that, what that one is. But this time, do we need to worry about this x is greater than or equal to negative 4? Actually, no, because that is the domain of h. And we're not plugging h into anything. So we don't care about that domain. What we do care about is the domain of our final answer. So we need to take this 2x plus 7 and figure out when that's going to be greater than or equal to 0. that is the domain we care about. If f of x had a restriction on its domain, we would care about that one too. We don't, because it doesn't. So the only domain that matters is the domain of the final answer. Okay. My goodness, my filter